Okay, so taking a look at 16.6.1 by request. This is on the basics. This is going to be different every time, but basically what you're going to do is you're just going to plug whatever this number is in for M and this number in for N. So it can be helpful to color coordinate these things so you don't get goofed. M I will do in pink, and N I will do in this maroon? Nah, fuchsia? Fuchsia? Magenta? I don't know. Something like that. So let's go ahead and do that. Wherever we place a number, we should probably put it in parentheses. So M is 4. And then let me grab a black pen. We're adding it to this guy. We got 5 plus 5. We're adding. So wherever there's an M, we're going to replace it with a 4 in this case. And then N will be replacing it with a 3. And the thing is here is, 1, you got to plug them in correctly. 2, you got to do what it says. And 3, you're going to need to get some commie denomies. So the bottom of this guy is definitely 8. Bottom of this guy is definitely 9. That's going to cause a problem in a second. 4 and 3, doesn't matter how you add them. They're both 7, which is convenient. Oh, dude, your knees. Holy cow. I don't think I should have. All right. Sounds awful. Let's get some commie denomies. The way we're going to do that is times by something that doesn't change it. So we're going to times by 1, but a weird version of it. Do you guys know what I should times this by to get it to match? 9 over 9, because we'll end up with 9 times 8 on the bottom. And if I times by 8 over 8, we'll end up with 9 times 8 on the bottom here. What's happening? Ooh, I guess it's not equal. It is plus. You guys are going to have to catch me on these things, guys. I am exhausted. All right, so looks like we're getting 63 over 72. And we're going to add it to, well, this is going to be over 72. That's why we did that. To 56 over 72. Do we add the denominators? No, please do not do that. Don't do it, don't do it, don't do it. I'm going to add 60 and 50 and get 110. And then add 9 and get 119. Well, you got the Greek yogurt? Is that what that is? Yeah. You know what's up. Waco's? Yeah. Or however you say it. I don't know. Just eat them. It's good stuff. All right. So, again, plug them in correctly. Don't goof that. Second, simplify and get like terms. Make them commie denomies. And then 3, for the love of God, do not add the denominators. That is not how adding fractions work. How are we feeling about that? Better is good. Some of it was factoring. And then, if you can find it, let me know. We'll do it. Yeah. Any other requests while we're doing freestyle? 15.2.3. Say no more. We're going to be jumping around like that one song. Jump around. I know that song because I was alive in the 90s as a child, and there was a Pringles commercial where they jumped on trampolines and ate Pringles. Did you say 15.2.3? Okay. All right. This is on page 3 of chapter 15's test. Remember, if it's not on the test, it's not on the final, so if you add up all the questions from all these tests, there will be less questions on the final. Especially, by the way, for those of you that are new, especially if it says, that one doesn't count, this is really a test. Remember, I labeled it wrong. That's really a test. But like on quiz 5, that's an actual quiz, so there's going to be a lot fewer questions on the final. And on 17, we never took a test, so this is a quiz, right? So there's going to be a lot fewer questions on the final from here as well. So let's go ahead and do this. Guys, here's the basic premise. We're not allowed to multiply to get rid of fractions. It just won't work because you could be timesing by a negative and that would change the sign. So we got to get commie denomies. So I'm going to show all of the work here, and it's going to get a little nasty. But first, I'm going to write down what we've got, and I'm going to subtract over that 2. And in order to get commie denomies, I'm going to do what we did last time with the 7 and the 8 or whatever, or the 8 and the 9. But I'm going to do it with this stuff. So I'm going to multiply by 1 minus x over 1 minus x. and I'm going to multiply by x minus 7 over x minus 7 here. Notice that's going to give us a denominator of these two, right? For both of them. Now the million-dollar question, what am I going to multiply the negative 2 by so it also has common denominators? I'm going to need both of those. See how it doesn't have any denominator? So I'm going to need to hit it with this. And I'm going to need to hit it with the purple. That way it has both on the bottom like the other two. Yes. I'm showing all my work, which is why it's going to be super messy. You guys might know that the denominator is going to end up being the pink, right, times the purple for all of them, right? Like this is going to have pink, purple. This is going to have pink, purple. That's going to have pink, purple. So they're all over pink, purple. In the top, well, over here we get 1 times 1 minus x. That's just 1 minus x. And then we're going to subtract 2x times the purple. Okay, that's 2x times x minus 7. And then we're also subtracting 2 times the pink and the purple. So I'm going to extend this out. And I'm making this nice and big, that way everybody can see it, but there's not a lot of room on this piece of paper. So if you can get away with writing smaller for your own eyes, I would encourage that. I'm going to pause right here, because that is probably like the most hectic part of this. After that, it's just simplify, simplify, simplify. So how we feel about, got to have everything have the same bottom. Now we do. 1 times this, negative 2x times this, negative 2 times all this crap. Okay. Now we're going to simplify. It looks like we've got 1 minus x, that's just that, minus 2x times all this crap. So we got to distribute. Negative 2x times x is negative 2x squared. Everybody cool with that? What's going to happen when I do negative 2x times negative 7? Positive 14x. Over here is my suggestion. You don't have to do it this way, but I like to multiply these guys first and save that minus 2 for later. So negative 2 times whatever I get out of this. 1 times x is going to get you x, and I know some of you guys are going to do this faster than what I'm doing, but bear with me. I'm doing it for a home audience. 1 times negative 7 is negative 7. So that's 1 to both, right? Negative x going to both is going to give us negative x squared and positive 7x's. I'm lazy, so I like using a little like ellipses down there. I'm not going to write the bottom every single time. I'm too lazy for that. And then we have to double everything and make it negative inside of here. So I'll write this out just so I don't make a mistake. All this is the same. And then I'm doing negative 2x's, positive 14, positive 2x squared, and negative 14x. All over the same denominator. And then we're going to combine like terms. So I'll pause, because again, making all this negative and, or negating all of it and doubling it, right? I'm going to change all the signs and double it. So now let's combine like terms. This is where colors can be really helpful. Let's do our x squareds first. Hey, look, how convenient. It's like I designed the problem that way. I wish I did that on every quiz. Negative 2x squared and positive 2x squared, gone. Then I'll combine all my x's. 14x, negative 14x, gone. But what about negative 2x and negative x? That doesn't go away. What do I get? Try again. Negative 3x's. Yeah, careful, careful, careful. This problem is really hard if you make little mistakes. So just go slowly and make sure you're not goofing. And then we've got 1 and positive 14. That's 15, right? So our denominator is still from before, the pink and the purple. And our numerator is actually really simple now, right? It's not that difficult. 1 minus x. That's what we want. Sorry for that scribble over there. And x minus 7. And we want to know, when is this going to be greater than or equal to 0? So let's talk about critical values, because we are nearly done, actually. So give me a number that x can't be, because it'll make us divide by 0. X can't be 1, because it'd make this 0 times something, and we'd be dividing by 0. And the other one, you're right, is it can't be 7, because then we're dividing by 0. Again, divide by 7 minus 7, that's 0, that's not allowed. However, x can be something up here to make this equal 0, right? What would x have to be to make this equal 0? You are truly my students. What is 15 over 3? It's 5, because... I'll take 15 over 3. I'll take that any day. That's beautiful. All right, so here are our crits. Let's draw our little number line in the tiny little space I have left. Before you get started, you should order these, right, from least to greatest. So it looks like 1 is going to go here, then 5, then 7. The spacing isn't super important. I just like to give myself lots of room. Now, we know you cannot plug in 1 or 7 because that makes us divide by 0. So what are we going to do? Open circle. It can't be that.
Why do we even put it at 15?
Because what we're doing, why 0 is so important? 0 is the number that is perfectly between the positives and the negatives, right? So if we were negative originally, which we do not want, wherever we can get 0, it has a chance of getting us what we do want. It could switch to positive there, right? So we're checking either side because we know at this point we've hit 0, and it could potentially switch to where we want, right? That's why it's critical, right? It's where it could change. That's why when we pick a number like 2 in between here, we don't also have to choose 3 or 4. That's because we know it's not going to change between 1 and 5 because it never hits 0, right? So wherever it is where it's going to stay until it dips down to 0 again, which will be at 5. Great question. I hope that made sense. All right, cool. So at 5, though, when we plug in 5, the top becomes 0. So we get, it is 0 over anything is 0. Do we want it to equal 0? Yes. Yeah. So this is solid. This is solid. So now we just got to figure out all the other areas where this will be greater than or equal to 0. Okay? So we're going to pick some numbers. Pick a number that is south of 1. How about, yeah, 0 is a great one. When you plug in 0, 0 times negative 3 is 0, and then you add 15, so that's going to come out positive, right? I'll make a little note of that. Our top is positive. In the bottom, when we plug in 0, 1 minus 0 is positive, and 0 minus 7 is negative. So we end up with something like this. A lot of you guys like to make the charts. I like doing this. The book does a chart thing. I don't know. It's useful later on. But for this, I think it's faster just to do something like this. If I have a positive divided by a positive and a negative, will that come out positive or negative? Definitely negative, right? Because the bottom will come out negative. Positive divided by a negative is a negative. Do we want this to be negative? No, we want it greater than 0, so we are not going to color in that area. All right, pick a number between 1 and 5. 3, okay. Well, if I plug in 3, we get negative 9 plus 15. That's definitely positive. If I plug in 3, I get 1 minus 3. That's definitely negative. And 3 minus 7 is also negative. So the bottom will be positive. Positive divided by positive is a positive. We want that, right? So we're definitely going to color in between 1 and 5. All the numbers between 1 and 5 will work the same way. Now, most of the time this alternates. But if you ever had a multiplicity of 2 answer, if you know what I mean, you know what I mean, right? If you had a multiplicity of 2, the odds of it being every other actually changes. It could be like 2 in a row colored in. This one, probably going to be every other, but we'll check a number anyway. What's between 5 and 7? 6. So let's plug in 6. We get negative 18 plus 15. That's negative. 1 minus 6 is negative. And 6 minus 7 is negative. So overall, this is going to come out negative over positive. That's a negative answer. We don't want that. So as predicted, we're not going to color in there. And then pick a number bigger than 7. I'll pick 70 billion. Super negative number plus 15 is negative, right? 1 minus a really big number is going to be negative, right? And a really big number minus 7 will come out positive, right? So overall, the negatives divide out, and we get a positive answer. That's what we want. This one is one of the gnarliest ones on there because there are so many little mistakes you can make that are going to screw you up. But the basic idea is this. Move it over, get commie denomies, simplify. That's it. That's it. Remember on the test, if you make small little mistakes, it's okay. If you can show that you understand the gist of this, but you accidentally forgot like an X here, and it screwed up your whole thing, do not go back and try and fix it and spend an hour on the problem. Instead, move on. I will notice, oh, they missed an X. So what are they bad at? Remembering their X's. That can be a good thing, right? Exactly. But do they understand the math? Yeah, 100%. Moving on, right? That's the beauty of the final. I'm here to see how far you progressed and what you know. I'm not trying to push you to be better anymore. So I'm more lenient, right? It's game day. Perfect in practice, and then whatever gets the job done in the game, right? You got to improvise. All right, what are we doing now? 15.4.1. Okay. So if you were here for basics, this is sort of it, right? There's a little bit of basic stuff going on in here, but a lot of these are going to be kind of trippy, so just hang with me, okay? We will get some basics if you're interested in basics. So here's the idea. This is a parabola because it's squared. And it opens up because this part is positive. This guy's going to open down, right? It wants you to find the minimum value. Well, luckily, there is a minimum value for this. It's the bottom of the parabola. We call that the vertex. So what we're looking for is the vertex. How do we find the vertex?
Why did you write the little guy point down?
This is downward because it's growing in a negative direction. Yep. Yeah, that leading coefficient, yeah, for the next guy. So see how this one's the maximum? Well, that's also going to be the vertex, right? In this case, that would be the max. Yeah, so either way, we're looking for the vertex in all these, right? To find the vertex, we got to complete the square. So what we're going to do is we're going to write A.
Even the square confuses me, because if you make both of them negative, then you wouldn't get AA, right? Because to get the negative inside of there, would you put a negative in?
You're asking a really good question, and I'm going to answer it over here so you can see it. So here's what we're going to do next. We know we're going to do a -4 here, right? And here is why. So here is the answer, Jax. Well, should I? Here, I'll do it here. That way the people at home can watch. Here is what this means, okay? Here's why we need half of this number always. Squaring means times it by itself, right? This gets us a squared. So far, this is no different than this, right? This is going to get us -4a, but isn't it going to get us that twice? That's why we need half. But we're not done. It's also going to get us 16. Is that in the original?
No.
So this thing right here is really close to our original, but it's not the same, right? So in order to get away with this, we got to have a -16 here, right? Because if you have a -16 here, then it is basically the original, right? You got to have the +4 too, though, right? That was part of the original. And now we haven't changed the problem. We've just made it look different. And that's algebra. If that's not vibing with you, don't worry about it too much. It's not super important at this point. But that's why we need half. And that's why we need to subtract 16. Because it's going to give us 16, and that's not part of the original problem. Now all we got to do is simplify. So it looks like the smallest I can make, this is what we're looking for, right? If I square something, what's the smallest number you can get when you square?
2. No, 4.
You can get even smaller. 0 is the smallest number you can get when you square, right? You can't go negative when you square without imaginary numbers, right? So to find the smallest, we want to make this as small as possible. What do we need to plug in to make this as small as possible? 4, right? So when you plug in 4 for A, so at A equals 4, this whole thing will equal what? 0 minus 12, right? So -12 is the smallest we can make it, right? We're always going to have that -12 there. The only thing we can control is A, right? So the best thing we can do is make this as small as possible so we get our minimum, and our minimum is at -12. It will always be this number, guys. It will. To find the maximum is the same thing. We're just going to find the vertex. Now, this one's a little bit harder because it does have a number in front of the quadratic term. So the first thing we're going to do is factor that out. You cannot divide this out because this is not an equation. When you divide, you have to do it to both sides, right? There is no other side. So we're going to factor it out. Taking out a -4 from here, we're going to end up with 10t, and we're going to end up with +9. And at this point, since this doesn't have a number in front of it, it's going to be easy to complete the square. That was the whole point of that. Don't try to do these two steps at once. You will goof. So now that we got it like this, I'm going to complete the square. We definitely need t, and we need half of 10, which is what? Positive 5. We know from that earlier demonstration, this is going to get us t squared and 10t, but it's also going to get us what? 25. And I don't see a 25 here, do you? So we better minus it, because otherwise we've changed the problem. And now we're here. The thing everybody forgets. Okay? Oh, not 34. This is negative. This is positive. The thing everybody forgets is they forget to distribute this negative 4 back. You have to do that because it will change what's over here. Our answer... Huh?
Can you wait till the very end?
You definitely can. You could simplify right now if you wanted, right? I usually don't because sometimes that negative 4 will get rid of fractions for you, and it makes it easier, but in this case, it really doesn't matter. In fact, it's probably easier to do it the way you were suggesting because the numbers will be smaller. Yeah. You'll get the same thing either way, right? You'll add these together, and you'll get negative 16, and you'll times it by negative 4. Either way, you're going to get negative 64. Or positive 64, I mean. Not really. Fun fact for all of you watching on YouTube, I'm actually a vegetarian. Yep. I've been one since 2009, so a very long time, which doesn't feel real. I often forget I'm vegetarian. Yeah, I often forget I'm vegetarian because like I just don't encounter a situation very often. Yeah, I know. Which is crazy because like so I just eat food, dude. I don't often have to think like, oh, I'm not going to eat that. It's not a religion or anything. I'm just choosing not to eat meat. But I used to eat hot dogs from this one stand when I worked as a janitor during the summer, during college. I worked as a janitor at my high school. And they had this hot dog stand after the 2008 crash. This one guy was doing construction, but he lost his job, so he started a hot dog stand. Crazy good Chicago dogs. We're talking, I know today with inflation, but even back in the day, full thing. 2 Chicago dogs, fully loaded. Homemade root beer. His wife was an elementary teacher, so they had all the kids taste test all the fries and the root beer before they, started doing it. And homemade fries, $5. Large drink, large fry, 2 Chicago dogs. Incredible. Insane. And I would have it when I worked during the summer, but then I became a vegetarian. Long story. And I went back over the summer. I was like, oh, I'm going to eat some Chicago dogs. What's the big deal, right? Do whatever I want. My stomach was not ready for that, so I had to give that up. So now I go to Portillo's and get their veggie dogs, and they're actually pretty dope. But for a long time, it was like the biggest thing I was losing was eating Chicago dogs.
How are they impossible?
They're all right if you do them right. They're all right. I don't like eating bad food, so I'm not about that life. It's got to be good. Why am I writing the same thing twice? Guys, at t equals negative 5, this whole thing becomes 64. So 64 is our max. Right? This number over here. This one's kind of annoying because it wants 2 answers, and we've got this a third thing going on here, divide by 3, right? So we're going to have to factor out that divide by 3, and the way you do this is you factor out a third. And I'll show you what I mean. Do you see if I were to distribute this back, I'd get 1 times x squared divided by 3? That's 1 times x squared divided by 3. The number I'm going to put here is not 2/3, it's actually 6. Because isn't a third of 6 going to get you back to 2? And it's 27. 27 times 1 divided by 3 is 9. So once we do that, this is actually not that bad. Well, if I distribute back, I should get back to this, right? Isn't a...
You're going to distribute it, and it's going to make...
It's going to divide it, right? That's what timesing by a fraction does. It times it by 1 divided by 3.
That's going to become 6/3.
Uh-huh, yeah, which is 2, yeah. Yeah, this is the...
Could you do 2/3, or is that...
What do you mean? Could I, like, put 2...
Could you have made it 2/3, or...
This right here, 2/3?
Yeah.
Nah, because then when you do it, you're going to get 2 over 9, right? That's not what you want. It's got to be 6. Only a third of 6 gets you 2. Only a third of 27 gets you 9.
What did you multiply to get 1/3 and then to get 2
So, see how this is divided by 3? this is what's tripping up everybody. Fun fact, this is the same thing as this. Do you see how x squared times 1 divided by 3 is this? So just treat it like you would a 4 or anything else, right? You're going to take out a third. Now, the thing is, when you put it back, you need to check to make sure you didn't goof anything. A third times x squared is this. A third times 6 is 2. A third times 27 is 9, right? So now let's complete the square. We need half of 6, which is what? Mm-hmm. And that's going to give us everything we want, but it's also going to give us 9. We don't want that. And now we just distribute that 1/3 back. That way we don't get the wrong number for our answer. -3 plus 9. And this thing doesn't want to know just what the minimum's going to be. Minimum's 6, right? But it also wants to know what number do you plug in to get that. Well, when x is -3, right? I don't know why the other ones don't ask about that, but this one does. You plug in -3 to get 6. All right, again, not a basic question, but as far as intermediates go, not too bad if this is your, 100th time seeing it. Yeah. And guys, I will scan this and upload it to Classroom afterwards, so if you don't want to write stuff down, that's totally fine. It's up to you. And I've got the ones from the earlier review as well that I can scan and upload. I just forgot. Huh?
What were those?
The ones that we did earlier today from 310 to 6. I don't remember what they were, but they're kind of all over the place, kind of like this. All right. What are we going to do now? She's been here. She's been here a very long time. She needs to go home and just stop studying. Seriously. Okay, well, no more math, okay? No more. You've done enough. You will be fine. I'm sorry. Oh, yeah, there was like a shiny Charizard in here earlier is what Landry was telling me. That's crazy. Yeah. So, remember, 12 is really the 5 one. And notice this is a quiz because I wanted to have them both combined to make it easier. So a lot of these problems will be removed before the final. But yeah, we can go over some 12s. So what do you want, Koa? No, it's cool. Relax. Don't worry. It took like 10 minutes for us to pick a problem in the last review. Yeah. No, I'm staying and helping out some kids to make sure things work out okay. Yeah. No, I'm not done until... Unfortunately. No. This week I always plug in everything for you. And that's for 2 reasons. One, because it would be insane to ask you guys to do that, right? You're going to have to turn in Chromebooks and all kinds of other stuff. And 2, I need this. Where is it? Where's the stack? Oh, it's right here. This is from yesterday. So I need time. So I'm just going to do it this weekend, and I'll do it for you. So I'm sorry to make you wait, but that's part of it. Yeah. Okay. So this one, 13.4.1 I kind of hate because it's like, basic doesn't mean easy, and this is a great example of this. Basic means this is the first thing you need to know about this new topic, but the topic itself was kind of tough, right? So it's a little convoluted, but I'll go over it, okay? Basically, it's saying we have this mystery equation, and one of the answers is this. Now, if you think about quadratic formula, it gives you your answers, right? Quad formula gives you the same thing, but it's just plus minus difference, right? So if this is minus a root, the other answer got to be plus the root. So there are your 2 roots, your 2 answers, right? Now, how is that going to help us find what B and C are? Here's how. The sum, the sum of our roots, the sum of these, meaning when we add them up, they're always going to equal negative B over A. Now pause. What is our A value here? What's the number in front of x squared? 1. So I'm not going to write B over A. It's just B over 1, right? So negative B over A is always your sum, right? So negative B over 1 is just negative B. And that'll always equal the sum of these, right? So if we know that to be true, let's add them up. What's 5 plus 5? What's negative root 6 plus root 6? It's 0, right? It's negative plus it's positive. Negative root 6 plus root 6 is 0. So this just adds to 10. So guess what? We just found b. If negative b is 10, what's positive b? Negative 10, right? Right, the negative version of negative 10, right? Yeah, okay, cool. So define c. If you know that the product of your roots always gets you c over a, and by the way, a is 1, so c over a is just c. The product is always c. That means all we got to do is multiply these, and we found c. So let's go ahead and do that. This is going to be a little bit messier. Okay, I'm going to write it out up here so you can see a little bit better. 5 minus the root of 6 times 5 plus the root of 6. You might notice they're conjugates, right? Oh, we're cooking. Here we go. 25. We're also going to get plus 5 root 6, but also minus 5 root 6. So what happens to the middle? Yeah, because it's a conjugate. That's what conjugates do, right? And then negative root 6 times root 6 is negative 6, right? You get negative root 36, and that's just negative 6. So overall, 25 minus 6, that's just 19. So C is 19. So again, it's the first thing you got to learn about this type of problem, but it's not necessarily easy. Again, if I wanted them to be easy, I'd call them easy. They're basic. Basic is not easy.
How did you know that 5 was B?
How did I know that 5 was B? Wait, what? Say again?
How did you know that the 5? Oh, wait, no, it's not.
Okay. What do you want to do now? We're taking requests.
Can we just go over 12 basic?
Yes. Yeah, if you guys are cool with that, we can totally do that. It's been forever, right? Some of these are really easy, and some of them are actually kind of the hardest ones we do. So yeah, the 5 quiz that has 12 and 13 on it is a tale of two cities. It has the easiest questions and honestly some of the hardest ones. Do I not? Okay, I will go.
You know, it's not a big deal. I can do that.
No, it's cool. I was printing some earlier, so I'll go grab it.
Thank you.
Yeah.
25. That's a big one.
Wait, what is it?
25.
Give me a minute. Wait, how much is it? 13?
Okay, my apologies to the Lorax.
Do you like have gym time or do you have weight? You guys feel like you
All those copies will probably go to waste, but that's okay. That's okay. All right. It's never a waste when we learn. All right, squaring means times it by itself, right? So that means this. What is negative 6 times negative 6?
30.
And what is I times I? It's true. I times I is negative 1. I squared equals negative 1. You've got to know this. You know what it is. Oh, for sure. Yeah. And if you're real good, you can do this like 5 seconds in your head, right? It's kind of what Milo did. But for the viewers at home, this is the logic, right? Negative 6 times negative 6 is 36. I times I is I squared. I squared is just negative 1, so it looks like negative 36. All right, so check this out. What's up?
Remember how you wrote my name as Jag's son? Jhagsen?
I don't remember that, but sure.
You wrote it on like a check sheet? I
Okay.
made that my TikTok name.
No way. Aww. Okay, that means a lot. Like, seriously. So, if this was just positive 9, what do you square to get positive 9? Or
Negative 3.
either of these square to positive 9, right? If you do 3 times 3, you get 9. If you do negative 3 times negative 3, you get 9. So where are we going to get this negative from?
Negative root, I.
I, baby. It's got to be I. Root of negative 1, yeah, sure. But it's I, right?
I got that.
Yeah, if you square, you're going to get 9. And if you square this, you'll get a negative 1, right? So together, you get negative 9. All right, so this one, let's think about this, right? If we divide by 5, we get this. What do you square to get negative 3? Well, we're going to need plus or minus the square root of 3 to get this, right? Are you smell what I'm stepping in, right? This will get you 3, right? This will get you 3. And then if you put I on the outside, you win, right? Because that's going to get you the negative. So again, yeah, 3 doesn't have a nice root, right? So it's just root of 3 plus or minus. And then the I gets you that negative sign. You got to have that I. There's no way you can square to a negative without I. All right, then we get, like, easy mode. Like, you just have to be able to read what they say. This is asking us to do what? Add them, not times. A lot of people think that these are the same, but they're not. You just got to read, right? Parentheses don't always mean multiply. So we're going to add like terms. So I've got 3 and I've got 7, which means I've got 10 because I'm adding them. And I've got 6i, and I'm adding negative 12i, which is minus 6i. Milo, you are on fire. Yeah, exactly. Yeah, there's nothing more you can do with that, right? I is not being squared, so it's just, you're stuck like that. So, next we're subtracting. This is where people get into danger. 4 minus 7 is negative 3. Yeah, caution, caution. And then check this out. Negative 7i minus itself is, of course, 0. Anything minus itself is 0, but another way to think about this is negative 7i minus negative 7i. That's really adding, right? Negative 7 plus 7 is going to get you 0. So we just get 0i. And what is 0i? Well, it's nothing. So the whole thing's just negative 3. And there you go. Now we're multiplying. So now you are allowed to distribute. Yeah, we're going to get 10. Yeah, we're going to get minus 8i. 15i. The confidence is off the charts. Holy cow. So yeah, this is going to be negative 12i squared, right? And negative 12i squared is really negative 12 times negative 1, which is positive 12. So yeah, when we combine all these things, looks like we got 22 plus 7i. Milo. The amount of growth this year out of you is like insane. Absolutely insane. Like, oh my God. I told you this yesterday. I went home and I talked to Abigail about my day, as we all do, and I was hyping you up. I was so proud of you. She's like, I don't know who that is, but good for that girl. There you go. All right, so now let's go ahead and distribute the 3 to everything. That's going to get us 8 and 15i. Or sorry, 24 and 15i. Thank you, Milo. She can't be stopped. She's too good. She's too good. Minus 5i squared. Yeah, and oh yeah, and as Milo already said, this simplifies to just plus 5, right? So all together, we're looking at 29. Yeah, a conjugate of a complex conjugate. That is a great question. So, yes. So there is a reason when you do certain things, okay, and you're like, ooh, the conjugate gets rid of middle terms, right? If you change this guy and not this guy, there are occasions where it will not get rid of the middle term. And this is because imaginary numbers are multidimensional. Long story short, if you're going to do complex conjugates, you have to change this. I found it out the hard way when I was like, oh, it doesn't matter, I'll just do this. And the math wasn't working, and I'm like, how is that possible? And then I realized there is a difference, but only sometimes. So long story short. However, this particular quiz, I think, does ask you to use the opposite at one point, which is kind of funny. All right, so guys, now we're going to get into some stuff that's kind of not great. This stuff's kind of tough, okay? This page in particular, this is so easy we never do it because it's just use quad formula. And then we're done. But like, yeah, this is where things get nasty. So look, they already completed the square for us, but what they want us to do is figure out when this equals 0, not like graph it. So the answer is not -3. That's not going to make this equal 0. That'll be 0 plus 5, which equals 5. So here's how I'm going to walk you through it. Because when you do it this way, you can actually feel confident in your answer. This entire term has to equal what? What do you add to 5 to get 0? -5. What do you square to get -5? This, right? If you square that, you get -5. Are you following me? Okay? But here's the thing. If that was our answer for R, it wouldn't work because they're going to add that 3 to it and screw it up, right? So here's what we're going to write, a -3 here. Now, go ahead and write that down. I want to walk through why this makes sense, because it's super trippy when you first start doing this, and then it's like, which is why we do it. Because back in the day, your boy was doing stuff, I get a weird answer, I'd circle it, and I just pray to God. Here you can actually see your answer and why it works. So imagine R is this, right? What's the first thing you do to R when you plug it in? What's the first thing it's asking you to do? Add 3. So if I add 3, gone. Then it says square it. When I square this, what do I get? -5, right? I get 5 times -1, right? And what is -5 plus 5? 0. This is the right answer. We got to have that -3 there to get rid of that. When we square it, it gets rid of the root and makes it negative. And we add 5 and we get it. This is going to feel very weird until you get more practice with it. And unfortunately, that's just not the time of the year we're in, right? This next one is really going to kick your butt because it's got that 2 in front of here that annoys everybody. So I apologize, we're not getting like 30 more of these to get you comfortable, but that's where we're at in the year, right? So hopefully we're seeing that plugging this in does get you 0, right? You add 3, it's gone. You square it, you get -5 plus 5. Over here, this has to be -16, right? -16 plus 16 is 0. What do you square to get -16?
4.
Yes, and if you want to, you can write plus or minus 4. I, right? Or you can write plus or minus root of 16i. I'll write plus or minus 4i because that's what you guys saw. So that works, right? When you square that, you get -16 plus 16. Exactly. It's got to be negative, right? And the only way you're going to square to get a negative is with I. Now, here's the thing. The first thing it's going to ask us to do is double it, and that's going to screw everything up, right? So what we're going to do is put divide by 2. That way when we double it, we get back to the thing we wanted. But the next thing they're going to do is ask us to -1. So there we go. That is our answer for x.
So you could also do x plus -2i plus 1.
Yes. Yes. Divide the 2, divide the 2. Yep, absolutely. So check this out, check this out. Here's why this answer makes sense. Okay? If x is this, the first thing they say is times it by 2. Gone. Then -1. Gone. Then square it, you get -16, you win, right? I'll do it again. First thing they say is double it. Gone. Then -1. Gone. Then square it. That's -16. -16 plus 16 is 0. But yeah, that times by 2 is what throws everybody off. The first thing they're going to ask you to do is double it. That'll screw everything up, so we got to put a divide by 2. Then they're going to make you -1. That'll screw everything up, so you got to put a +1. There's your answer. All right, now, the next two are just annoying. Those first two, it's like, okay, this is a thing. These are annoying because back in the day, when we were first learning something, see, these are section 1 of chapter 13. They're trying to get you ready for something bigger. They're trying to get you ready for complete the square, which I applaud them for. But now that they're actual questions, because I have to put the homework on the quiz, these are really annoying. So here's the idea. This and this are connected. They're equal, right? What is x plus a squared? Well, it's this. It is not just x plus a, or x squared plus a squared. It's this, right? Because x times x gets you x squared. X times a, and an a times x gets you 2ax's. And a times a is a squared. Once you expand that out, it's much more obvious what the answers are. So check this out. This part got to equal 12, right? Right? They're both the x's. So a got to be 6. So if a is 6 and these got to equal each other, right? A squared is 36, yeah? So that means c is 36. This is just getting you ready for, oh, I need half of this number, and right, that type of thing. Oh, it's going to give me 36, I got to subtract it. It's trying to get you ready for that. So this annoys me, but it was useful at the time. How are we feeling about this, right? This matches up with that matches up with that. Yeah, okay. Now here, when we expand, we're going to get y squared plus 2ay plus a squared. And the same logic. We know this part got to equal this part. So what's a got to be? -2. Good correction. -2 times 2 is -4. And if a is -2, what's a squared? 4. Yeah. A squared, right? You square -2, you get 4. And that means c's got to be 4, right? Because those are going to match up. So again, annoying. They're not really hard, but they're just kind of annoying.
What if I say something crazy to get you to demonetized?
Do not do that, because then, well, it won't be demonetized. They'll just take my entire channel down. I'm not monetized. Or at least, well, no, I might be. They might have given it to me. It's kind of like being on Twitter and they give you the check mark. You can say what Aubrey said yesterday that apparently didn't go, pop off. So, yeah. She was repeating what I mouthed, and I shouldn't have mouthed it. But anyway, this thing right here. It wasn't that bad, but yeah, probably shouldn't say that. It wants you to make it a square of a binomial. It wants you to turn it into something like this. Well, isn't this... This has to be this, right, to get 49? So when we expand this out, we're going to get 14x plus 49. So guess what c is? It's 14. I kind of wish they call it b, but whatever. Whatever. It's technically different. Now, this guy, if it's going to be a perfect square, it's got to be x plus what? 6, right, to get 36. Like this, you need to be 7 to get 49. Yeah, you're going to get x squared plus 12x plus 36, and that means c equals 12. Again, they're just kind of annoying. All right, now we're back into something we are going to be okay with. This wants us to find all solutions. This is not factorable. So our method... No. So our method is going to be to use complete the square to solve. We're used to using complete the square to graph, because a lot of you guys are like, right? And then we got to graphing, and you're like, okay, I'm feeling better about complete the square, and you forgot that it's actually originally used to solve unfactorable equations. So we need x plus 4 quantity squared. Do you smell what I'm stepping in? You smell what I'm stepping in?
Yeah.
Need half of this guy, right? It's going to give us 16. We don't want it. So now we get this. So, so here's what's going to happen. That's a 17. Now we're going to solve it just like we did the top two, okay? Like the ones that we did earlier. These guys, they completed the square for you and you solved, right? Here, we had to do the work, and now we're going to solve. So guys, this got to be 17, right? So I'm not going to need an I. That's a positive number. What do I square to get 17? Plus or minus the square root of 17. Now the problem is this cannot be our answer, because they're going to add 4 to it, and it's going to screw everything up, right? When we square this plus 4, it's not going to get a 17. So we got to have a minus 4 here. And again, check your answer. When you plug that in, add 4, gone, square it, you get 17 minus 17, you win. Whew. Yeah, 5 might be the most brain-hurty of all the basics. I'll be real with you. You guys really chose some tough ones to start with. Let's go ahead and flip the page. Now things are going to get a little bit easier. This is just quad formula, so plug in your numbers and don't screw it up. This is just what we were doing. No.
If I write it down, will you check it?
I can tell you whether it's right or wrong, but yeah. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so this right here, complete the square to solve. This one you can actually solve by factoring, but it says complete the square and use factoring to check your answer. I have to write the same directions as the book, otherwise people get confused. Just complete the square and solve. We need x minus 3, yeah? That's going to give us 9. I don't see no 9, so we better minus 9 in order to not change the problem. And here is the question now. When will this equal 0? Clearly, this got to be 4 minus 4, right? To get 0? What do you square to get 4? plus or minus the root of 4, or plus or minus 2. This one actually comes out nicely, right? And that's what happens. You get really nice numbers when it's factorable. This one's actually factorable. So plus or minus 2, when you square it, you get 4 minus 4 is 0. Then it's going to make you minus 3, which is going to screw everything up. So this is really what we want, right? Which you might notice is equal to 5 or 1, because this was actually factorable. Turns out you don't actually have to factor anything if you know how to complete the square. It works for everything, but it's sometimes simpler to just factor. So yeah, our answers are going to be 5 and 1. You can circle this, I'm fine with that, or you can write 5 and 1, because that's what happens when you do 3 plus 2 or 3 minus 2, right? Over here is going to be a little annoying. Do you know why? What's going to be annoying about completing this square? Yeah, half of 5 is 5 halves, right? And you might think, I'll use 2.5, but if I asked you what 2.5 squared is, you'd probably sit there and go, I don't know. But if I asked you 5 over 2 squared, you would know that it is 25 over 4, right? Yes. That's right, is what we need to put there to get rid of that. Now, at this point, we probably need some commie denomies, and I actually screwed this up yesterday, so Milo, what you have written down is wrong. Briley pointed it out. I wrote down that 2 is equal to 4 over 4. That is not true. 2 is not 4 over 4. It's what over 4? 8 over 4. Right? 4 over 4 ain't 2. That's 1. That's right. So what we're going to get is x plus 5 halves quantity squared minus, well, if we're adding 8 to negative 25, we're going to end up getting negative 17 over 4. So now, here we go. This one kind of sucks. You need 17 over 4 to get 0, right? 17 over 4 minus 17 over 4 is 0. Here's what you square to get 17. Yeah, I'm not even going to simplify, but yeah. I'm going to put it all in the root. You know what I mean? Right? Just because, like, let's just get it done. You need this so that when you square it, you get 17 over 4 minus 17 over 4. But they're going to screw everything up with this stupid add 5 halves, so we need to do minus 5 halves so our answer isn't goofy. Again, if you plug this in, you're going to see the first thing you do is add 5 halves. Gone. Then you're going to square it and subtract 17 quarters. You win. There's a level of confidence that this builds up. I'll admit, this is more complicated than just moving everything to the right side, but there's some dangers with that too. You never know if your answer's right because you're not really thinking. And also, that won't work for higher level problems. You're going to end up rooting things you shouldn't be rooting. Okay. Do it. Guys, the next thing is just use quad formula. I'll write that down. So you need to have your equation looking like this in order to use quad formula. Notice that this is like that. A is 1, B is 5, and C is 6. So it's ready to go. This is not, right? We got to subtract that 8 over. And this definitely isn't. You got to move all that stuff over. Here's quad formula. That's what x will be when you're looking for the whole thing to equal 0.
But the B and C, you don't have to do them, but can you, when you do
Right.
have the r squared minus 3r equals a, you have to like put them over like.
You need to do that. And then here, I'm actually going to add the t squared to the right so it's positive, and subtract the 6t. Because I think that'll be easier to plug in. 1, negative 3, and negative 1 plugged in. So A for this one is 1, B is negative 3, C is negative 8. For this guy, A is 1, B is negative 3, and C is negative 1. And you just plug those in. Yep. Technically, completing the square will get this job done too. In fact, that's where this comes from. It's just completing the square from here. Right? We did do that one time. Divide everything by A, take half of this. If you do complete the square with this guy, you actually end up with this. That's all it is. This looks a lot like the answers we were getting, right? Yep. Okay. That's it. We're done. No more. The hardest one is done. I really skipped over this, Jordan. It's just like, here's the quadratic formula. Use it, right? 1, 5, and 6, plug them in. After you rearrange this, 1, negative 3, and negative 8, plug them in, etc. All right, what do we want to do now, guys? First chapter is this guy.
And I know it's 14.
And we just did. First chapter of this semester was 14, though. What did you say? Yeah. So go ahead and grab 17. Flip on over to page 3. Yeah, this guy. This is a bunch of, can you read this and follow directions? Because if you can, you're golden, right? You got to know what it means, and then you got to do what it says. We want to find f of 2. That means we're going to go to the f function. Is the f function the left one or the right one?
Yep.
To the left, because it says so, right?
Take it back.
This is saying we want to find f of 2. That means we're replacing x with 2. We want to know what happens when x is 2. So isn't this where x is 2? Don't we get 2 comma 1? So when x is 2, we get 1. That's it. That's it. Just reading the graph. I'll use a different color for g of negative 1. G of negative 1 means we want to replace x with negative 1. We want to find out what happens when x is negative 1. That's right here, and you're never going to believe this. G of negative 1 is also 1, because these graphs aren't that good, and I'm too lazy to change them. They're straight from the homework. So yeah, g of negative 1 is, it just happens to also be 1. I don't know. I don't like when they give you coincidences like that. So here's what this is asking us to do, this abomination. It's saying, I want to take f of 2. Well, we already figured that out. What's f of 2? 1. And I want to g it. So I want to do g of 1. Okay, well, g of 1 is over here. Isn't that 1? G of 1 gets you 1, right? So this becomes 1 as well. It just so happens. And it wants to know f of that. So f of 1. So here's 1, and like it always does, it always ends up being this dot. F of 1 ends up being like a half, a third, a quarter, I don't know. You can write down something that is less than 1 and greater than 0, and I will accept it. Just estimate. Did that feel okay? Okay, that was kind of quick. How's the speed? We going okay? Should we slow down? Okay. What do you want to do now? Sure. 15's the one that kicks everybody's butt. I'll be real with you. Yeah, it's 14 but worse, and 14 did a lot of people in. What would you like to do on 15? All the basics? Something in particular? What do you want to do? All the basics. I got good news, I got bad news. The bad news is 15 sucks. The good news is there are literally only 3 basics on the test, which means at most I can give you 3. Bad news is I whittled it down a lot on the test, right? So I'm probably going to have to give you all 3, right? It's hard to get rid of this stuff. The way I get rid of... yes, but I don't remember what was on it. The way I make it is I ask myself, does this problem tell me the same thing as this problem about what you know? If it does, I don't need both. I'll just do one of them, right? So that's how I make the test. And then for the final, it's like, are there any ones that I can condense down further where I get the same information somewhere else, right? Sometimes you can. Like, for instance, a lot of the stuff in 12 and 13, isn't a lot of this like, do you know how to complete the square, right? Like here, right? Like, it's also solving it, right? But a lot of it's, do you know how to complete the square? I'm going to get that on 14, because you got to do that to graph, right? So I think if I had to bet, all 3 of these are probably on the test. So let's talk about them. They kind of suck. Originally on the quiz, this had 3 different versions of it. This is the worst version of it, so buckle up. We want to solve the inequality, and to do that, you need to factor. So let's rearrange this so it's easier to factor. Minus 21 less than 0. And this is going to help us find our critical points, and then we're going to test numbers and color and underline it. So brace yourself. There's going to be a lot in this little space. First thing we got to do, we got to factor out that 2. We got to do that. So let's factor out the 2. Oh, wait, hold on. Oh, stop. God, I'm tired. Don't do that. Don't do that. Don't do that. What am I doing? What am I doing? We're just factoring, dude. We definitely need 2x and x, right? I do the same thing you guys did on this one quiz. You guys all were like taking out the 2. So we know it's got to be 2x and x, right? That's the only way you're going to get 2x squared. What do we know about the signs? We need 2 numbers that multiply to negative 21. So what does that tell us about the signs? Yeah, it's got to be. You're never going to get a negative with double negative or double positive, right? Now, if I had to bet, the plus sign probably goes here and the minus sign probably goes there because we want to get a total of 11 x's. That's a positive number, right? So notice whatever I put over here is going to get doubled. I probably want to double something positive and subtract something negative to end up with a positive number. That's my guess. I could be wrong, but that's my guess. So let's stick with our guess for now and see if it works. 21. There's only a couple ways to multiply 21. If I did 21 and 1, if I put the 21 here, I'm going to get 42 minus 1. Not even close. If I switch it, I'm going to get 2 times 1, which is 2, minus 21. Not even close. It's got to be 7 and 3. Where do I want the 7? Where do I want the 3? That'll give us positive 14 x's, right? And if I put the 3 here, I get minus 3, which is 11. So we know 2x and x, that's locked in. 3 and 7 is locked in, right? The question is, do these actually add to 11? And they do. 14 x's minus 3 x's is 11 x's. So now we can say our crits, finally. That one was a tough one. One of our crits is negative 7, but the other one is not 3. It's not 3. What is it? 3 over 2. Notice if we plug in 3, we're going to get 6 minus 3. That ain't 0, right? If you plug in 3, you get 6 minus 3. That ain't 0. Because it's going to double it. If I put in 3 halves, when it doubles it, I just get 3 minus 3, right? That's what I want. So if I plug in 3 halves, the 2's divide out, and I get 3 minus 3. These are our crits. Negative 7 is smaller than 7 or 3 halves, so I'm going to put it on the left. You definitely don't want to goof the order on that. Now we know that these values are what we plug in to make it equal 0. Do we want it to equal 0? Nah, so it's open circles, right? Now we're going to find out where it comes out negative, right? Less than 0. So let's pick some numbers, plug them in, see what happens. Pick a number left of negative 7. Negative bajillion. It's actually really useful to do that instead of plugging in like close numbers, because the closer you are to this, the harder it's going to be able to tell where it comes out. So negative a bajillion doubled is super negative, and then we subtract 3. Well, that's negative, right? Negative a bajillion plus 7, well, that's still going to be negative, right? So what's a negative times a negative? Do we want this to come out positive? Nah, so we're not coloring that in. Pick a number between negative 7 and 3 halves. 0 is really easy to plug in. 0 doubled minus 3, well, that comes out negative. 0 plus 7, that comes out positive. So overall, we're coming out what? Negative, because negative times positive with real numbers is negative. We want it to come out negative. So we're going to color this in. Last one to check. Need a number bigger than 3 halves. Positive 60 billion, right? 60 billion doubled minus 3 is definitely positive. 60 billion plus 7 is definitely positive. Whole thing's positive. We don't want that. We want it to be negative. So there is our graph. Woo! It's a lot going on there. All right, this next one is super easy, but it trips everybody up. So that's the good news, that's the bad news. And then we've got one more, and the good news is it's the same every time. The bad news is you guys try to memorize it, and it's like so hard to memorize. The good news is if you don't memorize it, it's really easy. Yeah, it's like a catch-22. The backwards hat look, you're pulling it off. It's good. It's good. It's tough. All right, so to graph this. Normally, we have like something like this, and you guys are like, oh yeah, you plug in 2, right? See how this doesn't have anything there? It's basically like they've done this. What do you plug in to make this as small as possible? 0. So check this out. See how the plus 4 is over there? How do you make this thing right here as small as possible? You're going to plug in 0. And what are we plugging it in for, x or y? Plugging it into y. So 0 for y. Don't goof that up. That's okay. If we plug in 0 for y, so that's why the 0 is going in the y spot, this whole thing becomes 0 plus 4. What is 0 plus 4?
4.
So x is going to be 4 when y is 0. So that is your vertex, guys. It's that easy. It's like complete the square, but so easy everybody goofs it up. You don't even have to complete the square. So 4, 0 is where our vertex is. 1, 2, 3, 4. That's right here. Don't goof that up. 4 for x, 0 for y. Now, we know from chapter 14 that all you got to do is pay attention to this to figure out how it grows. Everything to the right of that is just to figure out where the vertex is, and we already got that. So check it out. Here's the situation we have. Forget about the less than sign. Just make it an equal for now. Let's figure out how this works. Let's make a little chart. We pick the same numbers every time. Why did I make that so big? Now, in this case, we're not plugging in numbers for x, we're plugging in numbers for y, right? That's the thing we're squaring. So we're going to pick the same numbers we always pick, plus minus 1, plus minus 2, plus minus 3. We're going to plug those in and get our points on either side. So let's think. If I plug in 1 or negative 1, and I square it, what comes out? But then I'm going to negate it and get negative 1, yeah? So what does this mean? This means that if I go up or down 1, because it's a y value, y is deal with up and down, right? If I go up or down 1, I'm going to go left 1, because that's what x does, right? It goes left. So up 1 is going to go left 1, and down 1 is going to go left 1. Again, y is deal with up and down, x is deal with left and right, x is negative, so it's going to go to the left. This parabola open and sideways. Because I paused for a second. So if I plug in 2 or negative 2, what happens when I square that? I get 4, and then it negates it to make negative 4. Yep. So what does this mean? It means from the vertex, not the pink dots. Always start here. From the vertex, we're going to go up or down 2, because those are y values, and go left 4, because those are x values. So up 2, left 4. 1, 2, 3, 4. Puts it perfectly on the y-axis. That's convenient. Makes it easy to graph. And it's symmetrical, right? Down 2 will go left 4 as well. What happens when you square 3? You get 9, but you're going to make it negative 9 because it said negate it, right? So that means up 3 gets left 9, and down 3 gets left 9. Do not draw your parabola yet. Here's why. If this was equals, we would have a solid line for our parabola. That's where it's equal, okay? This does not care about equal, yeah? On the line would be equal, so we're not including the line. We're not including our curve. That's where it's equal to. We don't care about that. If this had a sign like this, then it would be a solid curve, right? We do solid because it does care about equal, but this doesn't care about equal. So you can't include the actual parabola. We're almost done. Last thing we got to do is figure out where this is actually less than. We know equal is on the parabola. We don't care about that. We need to figure out where it's less than. So what I do is I always pick a number or a point that isn't on the parabola, because that's where that's equal. We're going to pick something that's not on it, like 0, 0 in this case, right? We're going to test it up here. If it works, everything in here gets colored in, kind of like that earlier one we were doing up here, right? If it doesn't work, then everything outside here will get colored in, because there's really only 2 options, right? Inside or outside. All right, let's plug in 0, 0. That means 0 for x, 0 for y. What is 0 squared? What happens when you negate 0? Still 0, so we get 0 plus 4 over here, which is 4. Is this true? 4 is greater than 0, so we're going to shade in here. Everything in here is what we're talking about. That's where it's less than. Whew. It is if you know what you're doing. It's super easy if you like have done it a couple times. If it's your first time doing it, there's lots of pitfalls, right? Let's turn the page. Should we do this one? I'm going to talk about the concept. Here's the concept. Step 1, write it down. Step 2, simplify. Step 3, run it back. If you do that and don't think about memorization, it's really easy, okay? You're going to get rid of fractions, you're going to get rid of roots, that's simplification, and eventually you'll run it back. What's up? So the arithmetic mean is this guy, x plus y over 2. And the geometric mean is this guy. It says the arithmetic mean is greater than or equal to.
Okay.
Yep, great question. All right.
Can we do
What do you want to do?
14 basic?
14 basic? Say no more.
And then maybe 16?
I'm sensing a pattern.
Just like
Yeah, right? I mean, that's what most people want to do, right? It makes sense, right? All right, 14 basics. Are you ready for like the easiest thing ever? This is the quiz that tripped everybody up, but it is so easy.
me and all.
Well, not you, yeah. But it is so easy once you know what you're doing. Guys, we need to graph this. It's going to be a parabola. We need to find the vertex. How do we find the vertex on a parabola? We got to complete the square. We've been doing that the hardest way on 5. I heard that. And we've been doing it the hardest way on 15. This is going to be a breeze in comparison, right? So let's go ahead and complete square. Notice there's no number in front of x squared, so just go for it. We're going to need x plus 5, right? That's half a 10.
Minus 25.
That's going to give us everything we want, but a little bit more. We don't want 25. And so when we combine our terms, we're going to very easily be able to see what number we need for x and what we get for y. So check this out. I know my vertex is the bottom. So it's whatever makes this as small as possible. Well, what's the smallest number you can get after you square it? 0, right? You can't get negative without I. So how do we make this equal 0 right here? What's x got to be?
X has to be
Negative 5,
Oh, 16.
right? And when you do that, this becomes 0 minus 16, so you're going to get negative 16, right? When you plug in negative 5, you get 0 minus 16. So there you go. So that's our vertex. Luckily, if you haven't figured this out by now, the grids that I use are 16 up, 16 down, 16 left, 16 right. So to graph this, we're just going to go 1, 2, 3, 4, 5 to the left and all the way down. That'll save you a lot of time.
And it's y and positive x, so it's
Yeah, so check this out. Remember, we grow from here. Oh, yeah, my bad. We grow from here, yeah? Everything else was to figure out where it starts, and we already did that. So now all we got to do is pay attention to this. I'll zoom out.
How much question can we ask you now?
Not very much.
Simple.
I'm going to do a lot of, and it's going to make me sad, but I'm going to do a lot of I can't answer that. I know it sucks, right?
The only thing that I feel like trips me up is that, the y equals x squared.
Yeah. Mm.
Or x equals negative y squared.
Yep.
For
I
this,
just
we
don't
need
remember
a
which one
lot
I'm
of
supposed to.
points.
So here's how you know.
The number you plug in is always the one.
Yeah, you want to plug, because you could plug in numbers for y, but imagine I plug in 1 for y. What do you square to get 1? What?
Then you would like to do.
Exactly, right. It's way simpler to plug in here and just square it and get your answer.
The numbers you're writing down for y, or, oh wait, no, they're always for x.
If,
And then plug in to get y, okay, yeah.
okay, if these were reversed, though, it'd be the other way around,
You
right?
plug in for y
Yeah.
and get x. Yeah,
So
okay.
if I plug in 1 or negative 1, when I square it, y will be 1, right?
You're not giving the number.
Mm-hmm, yeah, you're starting to put it together. Technically, you could do the reverse, but it's going to be way more complex, right? If I plug in 1 for y, well, then x got to be plus or minus 1, right? Like, nah. So, again, what does this mean? From the vertex, we're going 1 to the right or left, because that's what x is, right? Right or left? And we're going to go 1 up, because that's what y is. So we're going to end up here. Y is up or down. This is clearly positive 1, so it's going to go up. X is left or right. So there's the deal. How are we feeling about that, okay? Okay. 2 to the right or 2 to the left is going to get you 4. Again, go from the vertex, not from the pink points. So 2, 4. 1, 2, 3, 4. And negative 2, 4. And then 3 right or left is going to get you 9. And we can go ahead and draw this because, again, it does want when it's where it's equal, right? This is equal. It'll be equal on the curve. I go up. Okay, go
You
up.
got a card just in time to chill all summer on lunch. And then when it comes back, you still run away.
Yeah, Abigail's the one driving it. She's got to go to Sterling to.
She got the white, is it the white one?
Yeah, and we're trying to get rid of it. It's garbage. You don't want it.
What's the card you just bought?
It's a Chevy Bolt with a B
What
EV.
color is it?
It's like gray, like silver, pewter, something like that. But yeah, it's pretty dope, especially all these gas prices, and that's why I.
You have it yet?
Oh yeah. It's just she drives it every day, and we park it in the garage.
Oh, I was gonna say every time I go back to your house, it's just the white one.
Yeah, it's sitting out there because we have no room for it, and we're trying to get rid of it. And we don't park the new one on the street because literally, the reason we couldn't sell the white car until probably next week is because the week we were trying to sell it, somebody backed into it. So we never put the nice one out on the street. Yeah, and it happens. It happens. But like, it meant we had to delay to get it repaired so we can sell it. So we're gonna hopefully sell it. Kind of. Like, the reason we're selling is because when we were driving to Minnesota, her car way better than my Chevy Sonic. My Chevy Sonic has been like through it. You know what I mean? That's why we sold it. It's gone. I sold the CarMax for $1,000. I don't know why they paid anything for it. Oh my God, what a scam! They're like, we're gonna like. I got the offer online. I typed in. It's got engine issues, all kinds of stuff, and it does. Okay, and I know what I'm talking about because I've taken that thing apart. It is garbage. But anyway, so I take it in. And they're offering $1,000. I'm like, they're gonna check it out though, right? They're gonna check it out. And the guy looks at it for 5 seconds, and he's like, "Here's your check." And I'm like, because I'm telling you, like, he drove it from the parking lot to like into the service area, and it's like 50 feet. And we had to drive it all the way to Algonquin to like, please. Like, it'll start and everything, but like it's garbage. And so luckily he didn't check that much, and I got $1,000. Abigail's. We're going to try and do the same thing because the reason we're selling it is because originally we weren't going to. We were just going to have Abigail be our one car, right? Because I'm riding the bike anyway. But when we're in Minnesota and traveling around using her car, because her car is way better than mine, I'm driving it and I can feel the transmission slipping. Eventually I had to even stop on the side of the road, let the car cool down, transmission fluid to cool, so that it would actually catch and like drive the car forward. And when the transmission goes on that thing, it's over. Like, it's over. You replace that thing, it's going to be like $8,000. The car's worth like $2,000, right? So we need to get it to Algonquin, let it cool down, have the guy drive it that 15 feet, because if it doesn't cool down, he won't make it 15 feet, and then sell it for whatever we're going to get. I would never sell it to a real human being because, like, they're going to drive it and stuff. Like, I'm selling it to this evil corporation. I feel no guilt, but, like, yeah. Anyway, so that's what we're going to do. So you don't want that car. Everybody's asking me, like, Cole wanted to buy it. I'm like, girl, no. Steely wanted to buy it. Yeah, like, his mom was like, I need something for Steely or Dusty, and I'm like, if I can prove that I'm wrong about this transmission, sure, right? Like, whatever, right? Or I'll give it to you for free. Yeah, but no way. Absolutely no way. It is such a lemon. And so I had Mr. Dyer look at it, Sophie's Watts' grandpa, because he really knows what he's doing. I've taken an engine apart and done all that stuff, and so, like, I have a hunch, because Abigail's I'd never taken apart, right? I'd just driven it, and, like, it feels like a transmission problem. And he's like, oh, yeah, this thing's shot. So, yeah, we're gonna sell it to good old CarMax. All right, sponsored by CarMax. All right. No, CarMax will like eventually like have to take it apart and do stuff, and they're gonna realize it's garbage, right? But by then I will have cashed my check. So here we are. Let's divide by -2 so we can complete the square. So story time brought to you by Abigail's car. But yeah, my mom just sold her van that she had for a long time. It was a pretty good condition. It just had a little bit of rust. She got like $750 for it. My car, I got $1,000. What a steal! What a steal! It was like a Dodge Caravan, something. Right, but it was pretty modern. It's got like the DVD player, you know, for the kids and stuff. But she sold it like to actual people and only got $750. I sold my piece of junk and got $1,000. So life lesson. This right here is gonna be -4. We need -16 and +12. You guys follow me? Okay, cool. Now we have to distribute the -2 back. Everybody forgets to do this. You got to have y equals, otherwise it won't graph how you think it will. -2, do not distribute it into here. We're squaring. You can't distribute it into a square. And if we times both these by -2, because you're going to get +32 and -24. You could have combined those first and then distributed, but again, I tend to not. This is going to give you +8. So now we can see the vertex, and I'll pause. So it looks like we got to plug a number in for x to make this small. What number do you plug in? What number are you going to plug in for x to make this 0? 4, yep. When you plug in 4, you get 4 minus 4.
-16.
Nah.
What about the 2?
Here's why. When you plug in 4, 4 minus 4 is 0. Then you square it, you get 0. What's 0 times -2? 0, and then you add 8. Yeah, it's going to zero out this entire term and just give you 8. So 4 for x, 8 for y. If the x and y were switched, you had to flip it. Right, 4, 8 is where our vertex is. 4, 1, 2, 3, 4, 5, 6, 7, 8. And now that we got our vertex, all we got to pay attention to is this, right? Let's go ahead and make our chart. Looks like we're plugging in numbers for x. Our good old favorites. Plus, yeah. Now you know we're going to square all these, right? So we're going to get 1, 4, and 9. But here's the problem, right? After we square them, we're going to times by negative 2. So 1 squared is 1, yeah. But then you're going to times it by negative 2, get negative 2. 2 squared is 4, but then you're going to times it by negative 2. You're going to get negative 8. 3 squared, going to get you 9, then you're going to times it by negative 2, get negative 18. So here are our growth directions. Okay? There's definitely a joke in there, but I'm not making it. This right here. We're going to start at the vertex, and we're going to go 1 to the right or 1 to the left. And that's going to send us down 2, because y is up or down, and this is definitely down, right? So right 1 gets you down 2. Left 1 gets you down 2. Again, from the vertex, 2 to the right goes 8 down. 1, 2, 3, 4, 5, 6, 7, 8. Hey, right on the x-axis. Nice and easy to graph. And 3 going to send you down 18. So 3 to the right sends you down 18. This was already 8. So if I go 10 more, I get 18. 1, 2, 3, 4, 5, 6, there's 18. Now, this wants it where it's equal to, right? So go ahead and just draw a solid curve. This is where it's equal to, right on the curve. No shading needed. It's not greater than or less than, it's just equal to. I got great news.
We're done.
The ones after this are really easy. Like super easy, like the easiest. This is a circle.
Circle.
Yeah, that's right.
Gonna go home and eat
We're going to complete the square twice. But never fear, this is actually really easy.
That boy needs some sleep.
How late you staying?
Are you guys talking about me?
I asked you what you're gonna have for dinner.
Oh, dinner was like 2 hours ago. Abigail already ate it. I will be home. I will stay until at least 9. Tonight I don't have to stay super late. But if other people want to come in after 9, if they like pop in at like 8 o'clock or something, I'll stay until they want to go home. All right. So I rearranged this to get all my x's and y's near each other. Getting your x's near each other is a terrible idea in real life, but a great idea in math. Let's complete the square. What do we need here?
4.
Negative 4, not positive 4. Be careful, right? That's going to give us 16. We don't want it. Now when I complete the square again, I'm going to need y and 6 plus 6, yeah.
12, 36.
He's tripping, 36. There you go, yep. Trifling is crazy. And then the goal is to move everything that's not in these binomials to the right. So we're going to do that by adding them over.
15.
Fun fact, 69 nice, plus 16 is going to get you 85.
Wait, why are they? Oh, never mind.
Adding them all over.
Yep.
Good question. You're thinking the right thing. This is going to give me 85. And then when I add 36, it's going to give me 91 plus 30, which is 121. That is really good because 121 is what number squared?
11.
So technically, long story short, this is like distance formula. The distance from your center will be the root of 121. The distance from your center will be 11. The distance from your center is the radius, right? Our center is whatever the distance is, what makes it 0, right? What point is 0 away from the center? The center. So x got to be 4, y got to be negative 6. You smell what I'm stepping in? 4 and negative 6, 4 and negative 6. That's your center, because circles don't have vertices. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And then we're going to go our radius in every direction, 11 in every direction. So this is already 6 away, so I just go up 5 more. 1, 2, 3, 4, 5. This is already 4 to the right, so if I go 11 to the right, I'm going to get 15. That's right here. This is already 6 down, so if I go 11 down, I'm going to be at negative 17. Whoopsies. Off the chart.
Wait, how much do you want those dots by?
Our radius, which is 11.
Oh.
So I'm just like cutting to the chase because I already know it's 6 down, like 6 down. So if I go 11 further, I'm going to get 17, which is off the chart. And if I go 11 to the left, well, that's 4 and 7 more. 1, 2, 3, 4, 5, 6, 7. And then you draw this like massive circle. We are body positive in here. If you have a massive circle or a small circle, they're all beautiful to me.
How come no happiness?
It's a joke from my old school because my class, and it's so different at Polo. It's so different at Polo. But at like, yeah, like the old school, like I was like the wackiest, zaniest teacher ever. And I was allowed to be that because it was just a different environment. And so the joke was, you're not allowed to be happy in math class because everybody hates math, right? So that's a fake rule.
How else to be happy?
Huh? To get a 19%? Not very many, but so the final grade is weird, and I do it this for a reason. Okay, you know how they won't let me touch quarter 3 grades, right? It's like locked, which is like so stupid. So imagine you did really bad in quarter 3, and you had like a bunch of like 4s or something, right? Or maybe they were 7s, you want to give them to a 9. Imagine you get those right on the final, right? Because there is quarter 3 stuff in the final. Of course there is. I can't go in and change those to a 7 or whatever, right? So what I have to do is I have to go into Excel, like make my own spreadsheet, my own Skyward, and change the grade, see what it would be, and then I make your final grade whatever it takes to get it to be that grade, because you deserve that, right? So we've had people, like I had a kid in Algebra 1 who sucked quarter 3, right? But he did really well in the final. He got them all right in the final. So I should change all those to 7s or whatever, right? I had to give him over 100% on the final, even though I only did the basics, to make that grade fair. He still ended up with a 70 in the class, right, or whatever. But like, that's why some people are like, I barely did anything, I had 100. Well, that's because you didn't do anything quarter 3 and then did a little bit better to make it go up, right? So what should you do for a 19? Probably not very much, but everybody should do their best. And if you do your best, you have nothing to worry about. I did some predictions based on like some mental math in my head of where I think you guys are going to end up. Some of you are really fluctuant because you have a lot of like, quarter 3 wasn't great, but I think you know a lot more now than what you knew then. And so there's a potential for you to prove you know that, and it's going to go up majorly, or to not prove it still, and you're going to stay where you're at. So here are my predictions. Jordan. I predict you're going to get a C very easily. The question is it going to be a B or is it a C? That's my guess. Could it go higher? Yes. But C, I think you're pretty much locked. If you give me your best, I would imagine it's going to end up a C. And that's based on what I know you know. So if there's things you know that I don't know you know, you could get even higher. Milo, where are you at? Milo, you're highly fluctuant because you've grown a ton. So if you do what I know you can do, it's a B, guaranteed. Like, I would have no qualms about that. If you don't, you could end up a C or even lower. If you really prove beyond what I already know you know, an A isn't out of the question. Do you see how broad that is? Okay.
All I need to do is not get lower than a 52.
Right. So I think you're going to end up actually with a B. I think you're going to raise your grade a ton because I know that you've learned a ton in the last, like, even 3 weeks. Jackson, you're sitting at a B right now, a high B. You know your crap. You're going to end up with an A. I can't see a way you don't get an A. Right? I can't see a way you don't get an A. Now, does that mean nobody, like, when I predicted for you guys, right? Anybody can get an A still, really. They really can. Out of you 3. So it's not a question. I'm just doing based on what I know you know. So if you know more things than I know you know, you're going to do even better, right? But Jackson, I feel like I know pretty well what you know, and that's going to be an A, right? One of the benefits of doing it. Yeah, one of the benefits of doing it this way is I kind of already know what you're going to do before you even take the exam. Like, I know you well enough. I've memorized the mistakes you make, your tendencies. All right, anyway, that's it for the basics on 14. Do we want to do the basics on 16? Yeah, okay. I know. Tell me about it. I've been here. So, yeah, what can I do for you? Do you want to just go, or do you want to do something else? What do you want?
I feel like I'm good.
Jordan?
I feel like I got what I need.
Let's do it. Shutting down the video. Like and subscribe.